In problem number 11, in the xy plane, an acute angle with vertex at the origin is formed by the positive x-axis and the line with equation y equals 3x. And so we'd have a situation like in the diagram to the right. Now, the slope of that line, since we're working with an angle, the slope of that line can also be found using trig functions. So for example, in this case, the opposite side from theta is 3x, and the adjacent side is x, and therefore the tangent, or the opposite over the adjacent, would be 3, which is equal to the slope of that line in this case. So we could start with the equation that tangent of theta is equal to 3. Now what we want to do here is to find the slope of the line that is formed by the bisector of that angle. And we'll call that bisector theta over 2. Recall that the bisector of an angle cuts it in half, and so that angle would be theta over 2, and we're looking for the slope of that line. Now even from the drawing that I made there, as rough as it seems, you should be forewarned that you cannot assume that the bisector of the angle passes through the midpoint of the opposite side. If the bisector of the angle passed through the midpoint of the opposite side, then the height would be 3 over 2, or half of 3 over 2x, and so the slope would be 3 halves. That's a kind of a trap in this case, and since that is one of the answers there. However, we can go back to our what we do know. We do know that the tangent of theta is equal to 3. And from that, we can state that theta is equal to the inverse tangent of 3. Now, since we're looking for theta over 2, all we need to do is divide both sides by 2. And since we're looking for the slope of the line that is formed by theta over 2, I just need the tangent of theta over 2. So the slope of that line would be the tangent of tangent inverse of 3 over 2. Now we just need to use our calculator to find this. Now you might be wondering, and you should be wondering, whether we need to be in degrees or radians at this point. And I'm going to suggest that it doesn't matter, because we're taking the tangent and then we're taking the inverse tangent, or rather first we're taking the inverse tangent and then the tangent of that. So whatever we do, we're undoing, and it wouldn't matter as long as we used the same setting for both of those operations. It's not going to make a difference here, and you can try it with both. In this particular case, I am in radians, and if you wanted to try the same set of activities in degrees, you should see that you will get the same answer. So the first thing that I want then is the inverse tangent of 3 divided by 2, and that gives me 0.6245 in radians. Now if I were to take the tangent of that, it gives me 0.7207, etc., etc. And that is the slope of the line, which does make sense. It's less than 3, but it's not necessarily equal to half of 3. So we can see that the answer cannot be 3. The original one was 3. And the answer is not 3 halves either. So I have two other answers there, and I can think about them just briefly, or I could plug them in and see which ones equal the value that I have there. The square root of 10 is a little more than 3. Add 1 and I have a little more than 4. So that ratio is a little more than 4/3, which is definitely a lot bigger than 0.72. So I know that can't be the answer either. Square root of 10 is a little more than 3. Subtract 1 and I get a little more than 2. Divide by 3 and I have a little more than 2/3, which is about 0.72. Now if I were to plug that expression into my calculator, you would see that I get exactly the value that I'm looking for there. So your answer is D, and I think that would be done in a lot less work than the way that it was shown in the answer guide.